For our second example problem, we have here the track for this racing event was designed so that riders jump off the slope at 30 degrees from a height of 1 meter. And during a race, it was observed that the rider shown in the figure remained in mid-air for 1.5 seconds. So what we need to determine are the following: the speed at which he was traveling off the ramp, the horizontal distance he travels before striking the ground, and lastly, the maximum height he attains. And also, we need to neglect the size of the bike and rider when we determine this based in the problem. So, tula tong pangitaon, ang VA mo ng speed, which is equal to 13.4 meters per second. Ang horizontal distance before striking the ground, that is equal to R, that is 17.4 meters. And the maximum height he attains, which is 3.28 meters. So just a solution, ang first nato buhaton is we establish the coordinate system. So ang figure nato dire will be considered as our coordinate system since it shows already the X and Y axis, especially the initial position and its final position. So kanina figure dire sa atong problem will be our coordinate system, and the next step would be applying the kinematic equation. So ang first na pangitaon nato is the speed at which he was traveling off the ramp. So that is the initial velocity of your rider at point A. So when we solve that, we need to determine unsang iyahang initial position at what point. So that would be at point A. And also, we consider what would be its final position during this time. So ang iyahang final position is at point B, that is, it strikes at the ground. And from that would be from point A to point B. And once we determine the path from point A to point B, we can choose kung unsa tong gamito na equation. It could be from the horizontal or vertical motion. So depende sa given values nato sa atong problem. Nato yung given na values here na 30 degrees, napod tay height, which is 1 meter. And we have also the time, which is 1.5 seconds. So ang gamiton nato na equation is actually from the vertical motion, especially that the vertical motion na equation is the second equation, which is y is equal to yo plus voyt minus 1/2 gt squared. So ngano man kanya tong gamiton na equation para pangitawon ang speed sa initial speed or initial velocity sa imong rider, kay ang y without the subscript, that is your final position man, which is yb, is equal to 1 meter. And since it is below to your x-axis, that will be a negative. So ang imuhang YB is this one. So pababa man siya, that would be your YB. So that would be equal to negative 1 meter. For the YO, which is the initial position, that is equal to YA. And since the point A is our initial position and it acts on the origin, so ang atong YA would be equal to 0 meters or 0 meter rather. For the time, ang time nato is from point A to B and that is equal to 1.5 seconds. Kaya ang meaning manggod sa statement na it was observed that the rider remained in mid-air for 1.5 seconds, it means that um, ang time niya from point A to point B or the path from point A to point B is equal to 1.5 seconds. So ang time from point A to point B is equal to 1.5 seconds. For the gravity, since this is a SI unit, ang gamito nato is 9.81 meters per second squared. And ang ato ang initial velocity is equal to VA. And since we are talking about the Y component, which is this one, mo na to ang Y component sa initial velocity. So that is VAY. So ato ang VAY nato is equal to positive since it acts along the positive y-axis. So that would be VA sine 30 degrees. Nga naman sine 30, kay tungod ang 30 degrees nimo is opposite sa y component sa imohang initial velocity or the initial speed na VA. So once we knew already the given, we can now substitute here in our equation. So based from this equation, that would be YA is equal to, that would be YB because that is the final position, is equal to YA plus VAY times the time minus 1/2 G PAB squared. So we can substitute the values. This is -1 is equal to 0 plus VA sine 30 degrees times 1.5 seconds minus 1/2 times 9.81 times 1.5 seconds. So ang mabilin lang dire is the variable VA, which is the speed at which he was traveling off the ramp, which is the initial velocity. So just a continuation. That was -1 is equal to 0 plus VA sine 30 degrees 1.5 minus 9 point minus 1/2 9.81 1.5 squared. So we just combined the or transpose this term sa other side. So that would be VA sine 30 degrees times 1.5 is equal to -1 plus 1/2 times 9.1 times 1.5 squared. And that would be equal to 10.04. Then we just divide that with sine 30 degrees times 1.5 para ma-cancel out siya. and mabilin is the variable VA. So ang speed nato sa rider which he was traveling off the ramp is equal to 10.04 divided by sine 30 times 1.5. So that would be 13.39 meters per second. So that is the speed of the rider. That will be your answer. Let us check if that is the correct answer, 13.4. So if you round off, that would be 13.4. So that is 13.39 meters per second. For the next part is the horizontal distance he travels before striking the ground. So that is the horizontal distance he travels before striking the ground. That is equivalent to the variable r, which is this one. So ang gamiton nato na equation is still, it is from point A to point B, kay ang r manggod is measured from the initial position na A going to the final position na B. And the equation na gamiton nato is from the horizontal motion. Since this is a horizontal distance. So based from the horizontal motion, that was x is equal to xo plus vo xt. So ang given, ang x na walay subscript, that is the final position, that is the xb. So that is equal to the variable r. The initial position for the x component, that is equal to xa. And since it acts on the origin, that is equal to 0. Ang view x na to, or the x component sa initial velocity sa rider at point A is equal to VAX and can be found using VA cosine 30 degrees. Nga naman cosine 30 degrees, kay tungod ang 30 degrees angle nato at point A is adjacent sa imohang x-axis, and the x component sa imohang VA is acting on the positive x-axis, which is this one. So this is your x component sa velocity at point A, or VAX. So that would be equal to 13.39, which mao na tong gisolve kanina, and times cosine 30 degrees. And that would be equal to 11.60 meters per second. Ang time is the same na gihapon. That is from point A to point B, which is equal to 1.5 seconds. So we can substitute on our equation. So just a continuation. Ang final position is XB. Initial is XA plus VAX times the time from point A to point B. So ang XB nato is the R, which is the unknown. XA is 0 plus 11.60 meters per second. And the time is 1.5 seconds. So therefore, ang horizontal distance he travels before striking the ground is equal to 11.60 times 1.5, which is equal to 17.4 meters. So that is your answer for the variable r. Let us see if that is the correct answer, 17.4 meters. And lastly, ang next nato pangitaon is the maximum height he attains, which is represented by the variable h, which is this one. So ang points na i-consider nato dire to determine the maximum height he attains is from point A to point C. So that is from point A to point C. And since this is concerning on the maximum height, ang gamiton nato na equation kay gikan sa vertical motion. For the vertical motion, ang atong gamiton na equation is the third equation, which is the Vy squared is equal to Voy squared minus 2g times y minus yo. Nganong kanina equation itong gamiton? Because kung gamiton na to ang first and second equations, na variable na time, wala maguta kabalo pila ang time na covered from point A to point C. Kaya ang time given here sa problem, which is the 1.5, is the time from point A to point B. So the only equation na pwede na ito magamit for us to determine the maximum height the rider attains is the third equation. So ang Vy, which is the velocity at the point C, so that is the VCY. And ang VCY nato, since it acts on the, or it is at the maximum height, that would be equal to 0. Kaya di ba kung ang isa ka object, if it reaches its maximum height, ang iyahang velocity at that point or at that time would be equal to 0. Ang initial velocity nato with respect to y is equal to the y component simohang velocity at point A. So that would be VA sine 30 degrees. And ang atong VAY is this one. This same sa atong gisolve kanina sa previous slide. And since it is upward, that would be a positive value. So that would be equal to the velocity at A was 13.39 sine 30 degrees. So that would be equal to 6.70 meters per second. For the other given, ang imuhang gravity, since this is SI, that would be 9.81 meters per second squared. Ang Y, which is the um, final position, which is at point C, so that would be equal to YC. So it measures from the x-axis going to point C. So mao ni mo hang YC mismo. And since it is upward, that would be a positive value. And that is equal to h minus 1 meter. Ang h manggod is measured from the ground. And ang 1, ano mong h, and ang 1 is measured from the ground going to the x-axis. So mao na ang imuhang YC is equal to h minus 1 meter. For the YO, that is at point A, which is the initial position. And since it acts on the origin, that would be equal to 0. So from the equation, we can substitute the values. So that would be by squared is equal to boy squared minus 2g y minus yo. So this is your final velocity. So that is vcy squared. Your initial vy squared minus 2g times yc rather, because that is the final, minus the initial, which is t ya. So ang vcy squared nato is 0 is equal to 6.70 squared minus 2 times 9.81 times the YC is h minus 1 and YA is 0. So pag simplify nato ani, i-transpose nato ang 6.70 squared to the other side and i-divide nato with negative 2 times 9.81. So that would be h minus 1 is equal to negative 6.70 squared over negative 2 times 9.81. 2 times 9.81. And that would be, if we solve that, that would be equal to 6.7 squared over 2 times 9.81. That would be equal to 2.29. 2.29. So therefore, pag transpose sa 1 to the other side, ang height, the maximum height the rider attains is equal to 2.29 plus 1, or h is equal to 3.29 meters. So that is your maximum height the rider attains, which is equal to 3.29 meters. So if we go back to the solution, so that is equal to 3.28. So that is your answers for this problem. So the velocity at point A, or the speed of the rider which he was traveling off the ramp, is 13.39 meters per second. Ang horizontal distance he travels before striking the ground, that is 17.4 meters. And the maximum height the rider attains is 3.29 meters.